Okay, the next three problems are relating to this Keno game. So in a game of 4-spot Keno, the player picks 4 numbers from 1 to 80. The casino randomly selects 20 winning numbers from 1 to 80. The table shows the possible outcomes of the game and their probabilities along with the amount of money. The payout that the player wins for a $1 bet. If X is the payout for a single dollar bet, you can check that the mean of X is $0.70 and the standard deviation of X is $6.58. So I do want you to check that because sometimes you have to calculate that. And I would not do that by hand. I would put that in L1 and L2. Press that. So put that in L1 and L2. You can verify it with me. Pause the video so you can do this with me, and then press play so you can go through the stat menu with me. And I'll wait for a minute. All right, hopefully you've entered those in. You press stat, calc, one variable stats, and make sure your frequency list is L2. So the second one for L1 if you're in 83, second 2, frequency list, second 2, go down to calculate, press enter, and there's your mean, 70 cents, single payout, and then your standard deviation 6.58. So they're right there. So we can verify that on here. So how do we interpret the mean and standard deviation? Remember that you're not going to get a payout of 70 cents, but over many, many, many payouts, you would expect to get about 70 cents per game. Now think about that. You've bet $1, so on average you're losing 30 cents, but that's not what this question's asking. It's talking about the average. So you say 0.7 because it's in dollars and cents. If you were to play many games, not exactly one game of 4-spot Keno, the payouts would vary on average by about, well, what's the standard deviation? $6.58, so $6.58 from the mean. So the interpretation of it, obviously you'd want to write this down. You'd say payout average is $0.70 per game, which is a 30-cent loss on average because you're betting $1. If you were to play many games, not just one game, but many games of 4-spot Keno, the payout amounts would vary on average of about $6.58 from the mean. Now, why is that standard deviation so high? It's because of this 120. All right, that's really pulling that up. All right, next question. Jerry places a single $5 bet on 4-spot Keno. Find the expected value and the standard deviation of his winnings. Let Y be the winnings on a $5 bet on 4-spot Keno. So instead of doing a $1 bet, he's doing a $5 bet. So a $5 bet means that he's multiplying, right? A $1 bet is $1, $5 bet, you're multiplying. So you're multiplying. So that means that the random variable Y on a $5 bet is really just 5 times X. Again, multiplication affects both the mean and standard deviation. So multiplication affects mean and standard deviation. So really, you're just going to take your numbers and multiply by 5. So you got 70 cents, multiply that by 5. That's going to be your mean of Y. 7 times 5 is 35, so that should be $3.50. Standard deviation of Y? $5 times $6.58. So what is that going to be? $32.90. So make sure you put 3.50 and 32.90. Since this is dollars and cents, we have to have the right decimals in place. But that's it, just multiplying in those values. And the last question on this specific one. 4-spot Keno. Suppose Marla plays 5 separate games of 4-spot Keno. Five separate games of 4-spot Keno betting $1 each time. So she's doing her dollar bet. We're not multiplying by 5. What we want to do is we want to, since we're having individual games, that we're going to combine her winnings for her total winnings, which means we're really going to add, right? We're going to add those together. So if she's betting $1 each time, the mean is still going to be 70 cents. Standard deviation is still going to be $6.58. So if I basically treat this as you're combining random variables. Combining random variables. These are separate games, so they're independent. So separate games assume you can do independence. Which means you can add and add these together and combine them. So the mean, well, that's just going to be 0.70 plus 0.70 plus 0.70 plus, you get the idea, right? So that's actually just going to be times 5 because you're really adding the same thing. So that's going to be 350. But now this question wants to know what is going to be the standard deviation of x plus x plus x plus x plus x. Now remember, you cannot add standard deviations. You can only add variances. Cannot add standard deviations. You can add variances. So we don't want to just say 6.58 plus 6.58 plus 6.58. We want to do 6.58 squared plus 6.58 squared plus 6.58 squared plus 6.58 squared plus 6.58 squared. That's your combined variances. Then at the end, we would square root that. Take a minute to calculate that. I got 216.482. So that's your variance. That's your variance of x plus x plus x plus x plus x. So your standard deviation is going to be the square root of that. Okay, so what is the square root of 216.482? That's about 14.71. So it's approximately 14.71. So on average, she would win $3.50 and vary $14.71 from the mean. So this is a numeric entry, so just put the number in here and you're good to go. All right, that's the end of this question.